My dear students, very good morning. In the last class, we have discussed till acyl halides. We have discussed all the examples coming under this different classes of compounds till acyl halides. Today in this class, we will be discussing about the different examples under these class of compounds, that is amines, amides, nitro compounds and sulfonic acids. Now we will see amines. The functional group structure for amines is NH2. That means here towards the left side of this bond there will be alkyl groups or aryl groups. There will be alkyl groups or aryl groups. So based on the number of alkyl or aryl groups substituted, these two different structures will be obtained. And then if you see the IUPAC group prefix, amino will be added. Amino group will be added if it is a prefix, and the suffix will be amine. The suffix will be amine. Now we will see the IUPAC example. Here they have given you the structure as well as the IUPAC name. The IUPAC name given here is butane to amine. Butane to amine, and I'll explain you what are these, how you are getting these structures. NH2, NH and NH. Before going to this explanation, the example, I'll explain you the functional group structure, how you are getting this structure under amines. Now you see. Here the class of compound is amines. Amines. The functional group structure is bond NH2. Here towards the left side of this bond, already you know, I told you there will be alkyl groups or aryl groups. That means aryl group is nothing but C6H5. Alkyl groups are nothing but methyl, ethyl, propyl and so on. Here we will place the same group. We will place the same group. You see here how you are getting this. Actually, everybody knows what is ammonia. Everybody knows ammonia. The formula, the chemical formula for ammonia is NH3. The formula for ammonia is NH3. This is ammonia. Ammonia. See, if you replace one of the hydrogen by alkyl group, you will get like this. You will get this structure, R bond NH2. Now you can see here R bond NH2. So you are getting amine. Previously it was ammonia. Ammonia, you are having 3 hydrogens which are bonded to the nitrogen atom. If you are replacing one of the hydrogen atom with one alkyl group, you will be getting RNH2. This is the amine group. This is the amine group. Now, similarly, if you are replacing 2 hydrogens with 2 alkyl groups, you are replacing 2 hydrogens with 2 alkyl groups, you will be getting the structure R2NH. This is the structure, and this is also amine. This is also amine, but here these are categorized into primary amine, secondary amine and tertiary amine. These amines are classified into primary. This is primary because one alkyl group is attached to the nitrogen atom. See here how many number of alkyl groups are attached. Based on the number of alkyl groups attached, these amines are classified into primary, secondary and tertiary amines. Now here you can see, you can observe here how many alkyl groups are present here. Only one. So this amine is called as, this amine can be termed as primary amine. Primary amine. This is primary amine. Now how many alkyl groups are present here? 2. The number of alkyl groups which are directly connected to the nitrogen element or atom is 2. So this amine will be considered as secondary amine. Secondary amine. Very simple. This is nothing but the based on the number of hydrogens which are substituted or which are replaced by the alkyl groups. Here, if all the 3 hydrogens are replaced with alkyl groups, the formula will become N or 3. That's all. This is tertiary amine. Tertiary amine, because all the 3 alkyl groups are directly connected to the nitrogen atom. And you know, one lone pair will be present on the nitrogen atom. Lone pair. So lone pair is nothing but these are the pair of electrons which do not participate in the bond formation. So pair of electrons which do not participate in the bond formation are termed as lone pair of electrons. And the pair of electrons which participate, here you can see 2 electrons will be present in a bond. So these 2 electrons are called as bond pair of electrons. These 2 pair of electrons are called as bond pair of electrons. Now we will discuss the example under this class of compound. So this is the amines. This is the class of compound which is called as amines. What is the example they have given here? You see, butane to amine. They have given you the IUPAC name. Butane to amine. How to write the structure for this? See, first you should see the parent chain, that is how many carbon atoms, parent carbon atoms. 4. Buta means 4. At second place, this is the position of carbon atom. Amine is nothing but you should place NH2. As already we have discussed, you should place NH2 group. Now see here, simply you write down. First you take the parent chain, that is 4 carbon atoms, 1, 2, 3, 4. And then you number the carbon atoms, 2, 3, 4. 1, 2, 3, 4. At second, see here, you see the IUPAC nomenclature to amine. At second carbon, you are having this group. See here, this is at C2 carbon atom, you just link a group, that is amine. Now you just simply balance the carbons with hydrogens. Here 1, 2, 3, so 1 hydrogen. Here 2 hydrogens bond, and then the last one is CH3. So this will be the structure for this butane to amine. See here, amine, we have taken this as suffix. Okay. When 2 or more functional groups are present, then you can take the prefix form, that is amino. You can take amino. So for this, I'll take one example under the prefix. See here, one more example. Three amino pentanoic acid. 3 amino pentanoic acid. See here 3 is the position of the carbon atom, amino is the group. As you already know, this will be the NH2 group. This is the position of the carbon atom. Pentanoic means it is having 5 carbon chain. Acid, see here, one more functional group is there. Acid means you should add COOH group. You should have COOH functional group. Here how many number of functional groups are there? One is amino and one is acid. Here, see here, this is the substituent. Now you take pentanoic acid. Penta means 5 carbon atoms. You just place 5 carbon atoms. See here, and then you place the bond here. Okay, and then now you see the position of the amino group, at which position it is present. 1, 2, 3. Now I will write the numbers here. 4, 5, because pentanoic acid, penta means 5 carbons you should have. Pentanoic acid itself, here you should add this group here itself to the 5th carbon. If you are taking one more COH, it will become hexanoic acid. But here in this example, they have given you pentanoic acid. I have taken this example on my own. And here at 3rd carbon atom, you should have amino group. See here, NH2. That's all. Finished. Now you balance with hydrogens. CH2, here CH, here CH2, and then already we have got this group. Now 1, 2, 3, 4, 5. This is pentanoic acid. At third carbon it is given amino group. So 3-amino-pentanoic acid. This will be the prefix, example for prefix form. So finally prefix is amino and the suffix will be amine. So these are the structures I have explained you just now here. Here I have explained you the structures. See here, these structures are nothing but here I have explained you. Here these are those three structures. You observe here, there is a bond here. Here there is a bond. Here two bonds are there, and then for this nitrogen there are three bonds. There are three bonds. That means one bond means here you are having one alkyl group, that is RNH2. Here two bonds are there, that means two alkyl groups are present here, that means R2NH. And here you can observe three bonds are present, that means R3N. These are the bonds. Here you try to understand, dear students. Here two bonds are present and here three bonds are present. Simply you should understand that bonds are nothing but bonds which are left. Those bonds will represent alkyl groups. If there is there is no group, just the bond is left like that. You should understand that there is alkyl group. And then we go to amides. The amides, functional group structure for amides is, you can see here also the same concept. Here also the same concept which I have explained you in the earlier class of compounds. Amides, now you see the prefix CONH2 will be the functional group structure, and IUPAC group prefix will be the carbamoyl, and then amide will be the suffix which are used for this class of compound. Amides for this class of compounds. And then you see the example under amides. Butanamide. Here butanamide. I'll write here butanamide. The next class of compound is amides. Amides. The formula, the functional group structure is CONH2. Here also you are having bond. You are placing a bond. That means here also you may have alkyl groups or aryl groups. Now you can see here, if one alkyl group is present, that means here how many hydrogens are replaced? One hydrogen is replaced by one alkyl group. That's why the hydrogens are 2. If one more alkyl group is substituted, the formula will become R2CONH. R2CONH. So this is nothing but, see here CONH R, and one more bond is here. Here one more bond is here. So I have taken both alkyl groups here. One more bond is here, so I have taken two alkyl groups here. Okay, so in this manner you can replace hydrogens with alkyl groups. You can replace the hydrogens with number of hydrogens with alkyl groups. You will be getting those different types here. You will be getting these three structures. And then butanamide, we will discuss the example under this class of compound. They have given the IUPAC nomenclature. IUPAC name butanamide. Amide will be the suffix and carbamoyl will be the prefix. For this, first you check the number of carbon atoms, that is the parent chain, 4 carbons. Amide is nothing but CONH2. You should add this group CONH2. Now buta means you take 4 carbon atoms, 1, 2, 3, 4 butanamide, and this to this 4th carbon atom you should have this, just like acids, COH group. How you are taking that COH group, you have to take this group also in the chain itself. Okay, now you balance with hydrogens, CH3, CH2, CONH2. Finish. So 1, 2, 3, 4, this is buta, and then this is the amide group, so butanamide. Similarly, one more example, we will see the one more example. Propanamide. Simply you place 3 propane is 3, and then to the third you should have this amide functional group, that is CONH2, and then you balance this CH2 and then CONH2. So this is propanamide. So similarly you can take any number of examples, pentanamide, hexanamide, and then okay, and with the prefix form I'll explain you in another class with carbomoyl. Then we go to the nitro compounds. We will go to nitro compounds. See here, functional group structure is NO2. The functional group structure is NO2. And then nitro is the prefix. Nitro will be the prefix. That means these are the substituents. See here, you can observe this column. Prefixes are used only when these groups are present as substituents. And then here you see the example under this nitro compounds. 1-nitrobutane, they have taken 1-nitrobutane. Nitro, nothing but bond NO2. That means you can have alkyl or aryl groups. Now here they have taken 1-nitrobutane. 1-nitrobutane. Butane, 1-nitrobutane. See here, at first position nitro group, that is NO2, should be present, and buta means 4 carbon atoms. So you take 1, 2, 3, 4, and then you number it. You number the carbon atoms, and then you balance. You place the bonds at 1. 1 means you can take from here or here. So I have numbered from here. So you take here NO2. NO2. And then you just balance. This is CH2, 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 and then CH3. 1-nitrobutane. 1-nitrobutane. And then you can take another example. 4-nitropentane. 4-nitropentane. Simply at 4th position nitro group should be there. This is the 5 carbon chain. Then you write the structure here, 3, 4, 5, 4, 1, 2, 3, 4. Otherwise, if you are numbering from this side, 4, 5, this here, you can place the NO2 group to this carbon atom. Then you simply add hydrogens, CH2, 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 CH3. So this will be the structure for 4-nitropentane. 4-nitropentane. Next, we go to the last class of compounds, that is sulfonic acids. Sulfonic acids. Here you observe the functional group structure, that is SO3H. SO3H will be the functional group structure, and here the prefix used is sulfo. And the suffix will be sulfonic acid. And students, you should remember this table. You should remember this table very well, so that you can proceed or you can solve the higher questions which were given in your textbook or in your question paper or in your NEET paper or IIT JEE mains. See, you are very well in, or you are good in this basics, especially in the organic chemistry part. See here, in the organic chemistry, if you are good at basics, you can solve the higher level questions. If you are not having a basic knowledge, it will be difficult for you to solve. So students, please go through the basics before you enter into solving the higher level questions. Basics are very, very important. Whatever the subject may be, you should be thorough in first learning the basics. This is the last class of compound, that is sulfonic acids. As already I told you, sulfo is the prefix, sulfonic acid will be the suffix, and the functional group structure will be SO3H. Here one bond is there, that means groups are present towards the left side of the functional group structure. Now methyl sulfonic acid. See here, the example given here is methyl sulfonic acid. See here, sulfonic acids, SO3H. That means here alkyl or aryl groups may be present. Now here they have taken methyl sulfonic acid. Methyl sulfonic acid. Methyl sulfonic acid. See here, methyl is nothing but alkyl group. The formula for methyl is CH3. Sulfonic acid, the formula for sulfonic acid will be, already it is given in your textbook, bond SO3H. Now you add both this. Simply you just add both this. CH3 bond SO3H. Finish. CH3 bond SO3. See here, I am not taking this bond, I have taken towards this side. That means it is balanced. 3 plus 1, 4. So carbon is balanced here, and this is the bond for this group also. It should be balanced for both. Okay. Now this is the methyl sulfonic acid. This is the IUPAC name given, which is given in your textbook. I have written the structure for this IUPAC name. Now we will take one more example under this. One more example we will take. Butyl sulfonic acid. Butyl sulfonic acid. So first of all you should know the formula for this butyl group, that is C4H. Now you write here CH3, C2H5, C3H7, C4H9. So C4H9 will be the butyl group structure, and then you just add sulfonic acid group. Here you see, if you are not remembering the groups, you can write like this. You can write like this, and then you can place the group here. So this is the butyl group, this is the propyl group, this is the ethyl group, this is the methyl. So methyl, ethyl, propyl, butyl, and so on. You can go like this. Okay, so you can write roughly like this, and then you can place this group. So they have asked this butyl group. So this C4H9 is the butyl group. C4H9 bond SO3H. So before you solve any problem, you just take a rough. You should do roughly, and then you write down and then you solve the problem exactly. Otherwise you will lose marks. So with this class we have finished all the basics under organic chemistry part. Under organic chemistry part I have explained you all the basics. See here, dear students, from part 1 till part 8, that means totally 8 parts I have explained you, and all these 8 parts of my videos are completely about the basics of organic chemistry. After this we will go on to the lessons, that is first year intermediate organic chemistry part. So you are having 2 chapters from the first year, and then 5 chapters in the intermediate second year level. So I am going to take the next step of classes that will include your lessons. Directly we will go to the chapters. We will solve different examples or in-text questions, or the questions which are given at the end of the chapter. So at the end of the chapter questions are given. So students, please try to solve each and every questions which were given in your textbook, and then you please go through all the previous question papers. That means those who are preparing for NEET or JEE mains, you should be thorough. First you should be thorough solving the textbook. Textbook should be very thoroughly solved, and then you go to the previous, solving the previous questions which are given in your previous papers. Thank you, my dear students.